All right, we're going to look for the volume of solids created um, from a cross section of a shape on the ground or the base. So this says find the volume of the solid whose base is bounded by y equals x plus 1, y equals x squared minus 1, where the cross sections are perpendicular to the x-axis. They're rectangles basically with the height of 5. So that's good. Now keep in mind, when you want to find cross-sectional volume, you have to know the volume of a prism. And these are our prisms over here. You have your rectangular prisms, circular prisms are called cylinders. You can have prisms that are half circles. The main point of showing you this first is that you have to understand the components and where it is on the picture that we're going to be drawing. For instance, most of the pictures that will be drawn will be sitting up like this. But this, just because this is coming up out of the ground does not technically mean this is the base. The base, I'm sorry, the height of the prism. The height of the prism is when the base, which is the top and the bottom, they're exactly the same, is sitting on the floor, and this is the height, the thickness of the base coming up out of the ground. But when you draw it like this right here, this height is corresponding to that section right there. So when we draw pictures on our grid, on our base, depending on what shape it forms, and we start drawing these figures three-dimensionally coming out of the ground, we have to understand that this is the height, not this. This is considered to be your leg. Now, not all pictures are going to be half triangles. You'll have all kinds of shapes. Usually it'll be squares, rectangles, half circles coming up out of the ground like a dome, and we have to remember which one's base, which one's the base, and which one is your height. And the reason for that is because the volume formula for all prisms is basically two main components. You'll just be multiplying the area of the base, represented with the capital letter, and the height, which we normally will label it as dy dx, based on whether it's perpendicular to the x-axis or the y-axis. Okay, I went through that pretty fast. So if you want to review and just review that for a moment, go ahead. But let's work with this. Now I'm going to draw this two-dimensionally first. So you draw your floor picture. We call it the base. The base bounded by these two lines or these two graphs. Y equals x plus 1 is basically this, up 1 over 1. And y equals x squared minus 1 will start around here. And it's basically a parabola that goes like this. Okay, and notice that it's bounded here and over here. Now, you can start off by looking for the intercepts, but we're going to hold that off because we want to see we want to build a general equation so that we can actually answer the question. Now, you have to imagine that this picture, which is literally something that looks like this, okay, this is sitting on the floor, on the ground, and we're going to be drawing a three-dimensional picture coming up out of the ground using this as the base figure. Okay, so we're going to be drawing rectangles. The height is designated to be 5, or is fixed at 5. So I'm going to try this. We're going to be looking at a rectangle. It's perpendicular to the x-axis. So this right here, this red, will represent the base of the rectangle. And I'm going to draw it on this side. Now remember, this picture is looking top down. But if we look at it in a three-dimensional way, it'll look something like, I think like this. Here, let me draw this with a different color. Okay, here it is. All right. So this is going to be coming out of the ground, where this red part right here represents those two lines over there. Okay. So this is a rectangular prism. Now, if you put it on the ground, it should be faced something like this. Okay. And the red part will be like right over here. Okay, so it's, think of it like that. This is your base, and this right here is your height. So technically my height, even though this is coming up out of the ground, the height of the prism will be right over here. This will be your height, and we're going to designate this as dx because it's perpendicular to the x-axis. And if you draw more and more rectangular prisms, like this, I guess with my hand, this is three-dimensional, putting it like this, you're going to be making the width according to the difference of the length of your x-axis. You're cutting up the x-axis as small as you possibly can. Okay, so we know the volume of the prism is basically volume equals base times height. The height is going to be dx. So we're going to immediately change the h with the letters dx. Okay, so dx represents the height. And the height or the thickness of that is going to be thinner and thinner. Well, to find the volume, all we need is the volume of the base. The volume of the base is right here. This is the face, okay, of the base. Okay, the height is always going to be 5 and it's going to be fixed. But the real question is, how do you designate this length right over here? Okay, to find the area of the base is going to be, length times width, or height times base, or whatever. It all depends on how you want to look at it. But basically, we have a rectangle. This side is 5. The question is, how long is this? This length is determined by this right over here. It's the blue line, the y value there, minus the coordinate on the parabola. Okay, so let me repeat. This length right here, if I can just move it over, is basically this. Okay, so we need to find a way to designate this leg right there. So we'll call that, we'll just call it like a y value. Okay, so no, I'll just use a letter like d. Okay, we want to find d. So how do you find d? Well, notice that it's going to be the y coordinate on the line, which we will call this y2. And this coordinate right here, we'll call it a y1. So it's going to be y2 minus y1. And where do we get those y values? Well, we get it from these two equations. The top equation is y2. So we'll call this y2. This will be called y1. So it's basically x plus 1 minus x squared minus 1. Okay. So if you simplify this out, this will become x plus 1 minus x squared plus 1. And if you further simplify this, this will become negative x squared plus x plus 2. Okay, so this right here is this part right over here. Okay, the letter D, this length, that's how it's going to be designated. So now the question is, how do you find the area of the base? Okay, that's easy. It's just, you just multiply the two sides. So the area of the base, the letter B, will be this, we'll call it D times what? 5. And D is represented with negative x squared plus x plus 2 times 5. So if you multiply everything out, this will become negative 5x squared plus 5x plus 10. That's your area of the base. And we're going to put this right here, and we're pretty much done. Okay, I'm kind of running out of space, so I'm going to just do it like right here. Okay, so I'm going to fill out this equation. So let me write it right here. So this is going to be my b times dx, okay, which will give us the volume of that figure. So volume equals negative 5x squared plus 5x plus 10 dx. Now I want to establish and write this as an integral now. Negative 5x squared plus 5x plus 10 dx. And all we now have to do is figure out where we're going to be building these prisms. So as I told you in the beginning, this is where you have to find the two intercepts. Okay, because we're going to be drawing it from here all the way to here, and everything in this little sector is a bunch of these rectangulars side by side, but in a very, very thin, infinitely thin manner. You add up all of those thin rectangular prisms and you'll have your volume. Okay, so I think it's I think it was -2 to 1, I forget. So let's try this. set the equations equal to each other and look for their intercepts. So we have here y plus 1 equals x squared minus 1. And we're going to set this equal to 0 because this is a quadratic. So x squared minus y minus 1 minus 1. So x squared minus y minus 2. You factor this out, x minus 2, x plus 1. So you have x equals 2 and x equals negative 1. Okay, so from negative 1 to 2, that's this. I guess I could just put it right here. This is negative 1, and this is positive 2. So our integral will be from negative 1 to 2, and we're done. Well, we're done setting up the equation. So this I would count to be as 90% of the problem, and the rest is just a simple integral and evaluation. All right, so let's try this. Hopefully we'll get it right on our first try. The antiderivative of this will be negative 5x cubed over 3 plus 5x squared over 2 plus 10x, and we'll evaluate this from negative 1 to 2. All right, so let's plug in the 2 first, and then we'll plug in the 1, and then apply our fundamental theorem of calculus and I know, was that FTC? Yeah. And then we'll have our answer. Okay, so negative 5 2 cubed over 3 plus 5 times 2 squared over 2 plus 10 times 2, and then minus, and then I'll do the second part in a different color. So negative 5 times 1 cubed over 3 plus 5 times negative 1 squared over 2 plus 10 times negative 1. Okay, so what do we have now? We have negative 5 times 8 over 3. And again, I just want to remind you, this is just algebra 1. It's just a bunch of fractions with exponents. This is not the hard part of the math. The hard part is building this equation. This is just, adding and subtracting. But this is where students mostly get it wrong because they kind of rush through it. So just take your time. Hopefully I won't get it wrong too. So plus 5 times 4, 20, 20 over 2, plus 20. And then inside the bracket, you get negative, let's see, 5 times negative 1 is positive 5 over 3, plus 5 over 2, minus 10. Okay, so now let's further evaluate this. We got negative, let's keep our colors consistent, negative 40 over 3 plus 10 plus 20 minus 5/3. Well, here, let's distribute that out. Okay, I'm going to just change this all into one color now. Negative 5/3 minus 5/2 plus 10. Whole numbers, this will be 30 and 10. That will produce 40. And then these two have same denominator, so that will be negative 45 over 3 minus 5/2. And then you can get common denominator for those two. So it's 6. And then 2 times 45 is 90. 3 times 5 is 15. And we have 40 minus 90 minus 15. That will be 105. And we have to get common denominator here. So 240 minus 105. Which will give us 5, 3, and 1. So 135 over 6. And can we divide it? Yes. If you add up anyways, that's just all right, so I'm just gonna use my calculator. We'll divide it by 3. So 135 divided by 3 is 45. 6 divided by 3 is 2. And the answer is 45 over 2. And that is the right answer. So give that a try.